Welcome to this short presentation on the implications of loss model structure on simulating large floods. Typically, engineering flood design begins with the consideration of a design rainfall event, which is converted to runoff using a rainfall routing model. But before this occurs, the rainfall needs to be portioned into the part that directly contributes to the runoff and the part that doesn't. The part that doesn't is typically termed loss and consists of things like infiltration and depression storage. So what loss models are used in practice? Initial continuing loss conceptualizes losses as an initial abstraction with a constant infiltration once the soil is saturated. Initial proportional loss is similar but conceptualizes the loss after the soil is saturated as a proportion of the rainfall. The curve number, SCSCN, and probability distributed models, PDM, assume that proportional loss decreases as a function of the event. So which model is best? Here we used a set of 35 calibrated catchments across Australia to test the performance of each loss model as it would be used in practice, to extrapolate to large design flood events. As may be expected, all models were unbiased for the range of events usually observed. But as the events got bigger, so the bias got bigger, with initial proportional loss, SCSCN and PDM all underestimating the modelled flood peak. Only initial continuing loss remained unbiased for large events. So in extrapolation, the initial continuing loss model was best. But why? Well, this is because losses are a function of the catchment properties, and initial continuing loss is the only model independent of the rainfall intensity. Thanks for listening. More details can be found in the following Journal of Hydrology publication.